start. I actually feel like I'm in a company that's like a baby brother to Google, because their scale and our scale is a little bit different, but our scale is still fairly large, and we have those problems with developing applications at scale. So this is a little bit about me, more about me, about my team, which is actually a team that's somewhat similar to Sierra's team. It's both smaller because the company is smaller, and it also has slightly broader agenda, I guess. So that's basically what makes it difficult to fill in the shoes. I wish we had or we could take a principled approach as Google is taking to improving developers' experience, but we're too busy putting out fires basically at this point. So I'm going to also switch gears a little bit in this talk. I will basically talk a little bit about specific projects that my team is working or has been working on to tackle problems that are related to developing applications at scale. So that's roughly what my team is doing, or what it's trying to do. We're trying to improve developers' experience, but we're also working on improving application reliability and performance. And I'm professionally interested in PL in general, programming language implementation, although we don't really do that much of that at Uber, at this point at least. So we're also developing at scale. We have slightly smaller scale, but we still have thousands of engineers. We have a lot of applications, both on the backend services, and actually people probably know like 2 or 3 Uber applications, but actually about 20 different mobile applications, a lot of them being used internally by basically people that help drivers and authenticate them and such. And the code base is large. We also are sort of moving towards the monorepo architecture similarly to Google. So cumulatively, we have millions of lines of code in all our repositories. So if you want to do anything on basically a more cumulative code base, it's becoming a challenge. And so, like Sierra said, there are certain things that just don't work at that scale at Uber, like neither open source tools nor commercial tools actually sometimes. So we have to develop our own solutions in many cases. But we're also trying to contribute back to the community. We are pretty big in open source. I mean, obviously, we're not the only company that is trying to be present in open source, but I actually like the fact that there is actually an emphasis in the company on contributing back. We take back from the community and we contribute back to the community. So in this talk, as I mentioned, the talk will be a little bit different, or actually a lot different than the previous talk. I'm going to basically tell you a little bit about a few projects that we've been working on at Uber in my team and with some collaborators. The first one is they basically reflect the agenda that my team sort of has in front of us. So the first one is a little bit on the developer productivity side. The second one is on application reliability. And the third one is sort of related to performance. So basically all the boxes are ticked. So let me start with the first tool. So basically it's fresh off the press, very sort of new project that we've been working on recently for maybe 6 months or so now. So what's the background? What's the motivation for this work? As I mentioned, we have a lot of backend services. Most of you or all of you probably know what that means. There is a loosely coupled architecture of different interacting smaller application services that talk to each other and try to accomplish sort of a larger goal. There are certain great advantages to this architecture. That's why a lot of companies are moving from the monolithic architectures into the microservice architecture at this point. And some of those benefits are rapid development, because every microservice can be developed basically independently, and also can be deployed independently, provided that, of course, it fits into the whole ecosystem. However, testing and debugging of the whole system is a little bit more complicated. Like if you have a monolithic application, basically you can throw a debugger at it, maybe, and try to sort of figure out what's going on. With loosely coupled architecture, that's actually a little bit more difficult, because if you debug or log information from a single microservice, then you only know what this microservice is doing, or that there was a failure within that microservice, but you kind of don't know the context. So they can't really be fully effectively debugged in isolation. And this execution context of the whole system is kind of required to be there for basically effective debugging and effective logging. So specifically, this project and this problem that we're tackling right now is related to microservices written in Go. Uber basically has settled on two main languages in the backend space, which is Go and Java. So the context, there is a way sort of to abstract, to encapsulate context in Go, which is kind of suggested or recommended by Go, and there are certain libraries that are provided that basically let that happen, let the programmers do that. So basically have context, propagate context through the code of the microservice. The propagation, though, is kind of complicated. So in other languages like Java, there are things like thread local storage. So basically at the entry to the service, you can basically put the context that's coming in from the upstream service into the local storage, and at the point when you need it, just grab it from the local storage and you're done. In Go, this mechanism doesn't exist. There's no such thing as thread or Go routine local storage. So basically Go or Go team recommends that the context is propagated through the code of the microservice by passing it explicitly as a first argument to all functions. So if you have a library function that needs context, basically all the functions in the call chain that leads to that function, according to the sort of canonical way of passing context, will have or should have this context pass as the first parameter. And if you write a service and you kind of have it in mind, I guess it's not super difficult. I mean, you can do it, right? You basically have to remember that there is a context parameter that comes first. The context values comes the first parameter. Just keep passing it, and just you have to have certain discipline when you write your code, but it's manageable. But if you actually already have an ecosystem of microservices and you introduce a new API that is context aware, and the calls that lead to that particular API call do not have context as the first argument, then it's a bit more of a problem. I mean, it's basically a refactoring nightmare if you have large code bases and if you have a lot of services. So you can imagine, junior engineer just sitting there for hours and hours just trying to figure out where to add context so that actually everything works. So that's very sort of counterproductive. We wouldn't like to expose our engineers to this kind of task. But there is also not existing tooling support, at least not as far as we are aware, to basically facilitate this kind of refactoring task. So we decided that we're going to build such a tool in-house and try to help our developers basically in this fairly tedious task of adding this context parameter to functions and context argument to function calls. So basically, how does the tool work? So as an input, you will get a list of library calls that at the sort of leaf level that need to get the context argument. Then you will build a control flow graph, and that would trace all call chains that originate in those, or actually they end in those library calls upwards to the service's entry points. You would remember basically which functions and which function calls require the context argument, and at the end, you would take this information and modify whatever internal representation you prefer. In this case, or in most cases, would probably be ASTs, spit out the modified source code, and be done. So that's what the tool does. The caveat here is that it's a best effort tool. I mean, it basically, because you construct the control flow graph statically and you do this transformation statically, it can't take care of all the corner cases. But the aim is to reduce the majority of the grunt work that the developers would have to otherwise do by hand. And I'll tell you a little bit about how that actually worked out. So just to give a more concrete example, very simple example, what the tool would do. We have a very simple code in Go, two functions. One calls the other. So foo is the sort of top-level function. Bar is the inner function, or the leaf function. And then we have a log API call, or a call to a logging function, basically logger log. So what the tool would do, or the programmer, if they had to do it manually, they would add context parameters to both functions. They would add context argument to both calls, and that's optional. If you're basically modifying the API, you would rename the function for the one that's context aware. So it looks super simple, doesn't it? Like it should be very, very straightforward to do. Unfortunately, Go is a fairly complicated language and has a fairly complicated ecosystem, and that makes things a little bit more difficult. So I'm going to highlight some of the issues that we had to tackle with. Hopefully that's going to get open source soon, as most of our other projects. So you'll be able to sort of take a look yourselves. At this point, we're working on it, on open sourcing this. So one of the language features that Go has are interfaces. Everybody's familiar with interfaces, but I'm not sure if everybody's familiar with interface, how interfaces work in Go. So this is a simple example. We have a very simple interface with one function defined in it. So the way it works in Go is that you have, okay, I'm not sure how much I should talk about the details of the language, but basically this is a method in Go. And the method has a receiver of a specific type. And if the signature of this method is the same as the signature of the method in the interface definition, we say that this type implements that interface. Okay, so hopefully that's fairly straightforward. This can be a pointer, but it doesn't have to be to the actual type. So this is a very simple example, and of course, similarly to the example that we had before, for the sort of leaf function, you have to rename it. We have to add the context. We have to add the context argument, and then we have a function signature that has to change. That's really nothing really changed compared to the previous example. But of course, because the type, the receiver type of that function, of that method, implements the interface, in order for this to be automated, we have to change the definition of the function in the interface as well. And the struct type is unmodified, obviously. There's nothing to change there. And it also looks, relatively simple, but there's a lot of sort of little things like that that have to be taken care of when building this kind of tool. In this particular case, there are additional challenges. One of them is that it's an iterative process. So if you modify a function signature, and you modify interface definition, the function definition in interface, there may be other functions that implement that interface that suddenly need to have a context argument as well. An additional complication on top of that is that the implements relationship in Go is implicit. So in Java, you basically know which type implements which type or extends which type. In Go, this is not the case. You basically have to go through all the signatures of the functions and see if they implement a given interface. Otherwise, there's just no way for you to know. So that complicates things. And this very similar mechanism is applicable to other language constructs, in particular first-class functions. So you have parameter types that can be of type functions. So you can pass functions to other functions. And you have to basically do a similar thing, change the definition of the type of the parameter to add a context argument. But it's kind of very simple, very similar to that one. Another complication, again, there are more. I'm just highlighting a few examples so that you don't think this is like a super trivial thing to do. Is that Go has testing harness. So you can type Go test, and then functions with certain signatures will get executed, and the results are going to tell you if your service or your application actually works correctly. The problem is that this signature for these test functions is fixed. So the test harness recognizes those functions by the signature and the name, but signature as well. And so you can't add a context argument to those signatures, otherwise they won't be recognized by the harness. So what we do instead, this is a simple tip. So this is basically a definition of a test function. So it has to have a prefix test in the name and has to have this particular signature. So what we do for these and for other cases is we're basically saying, first of all, it's a test function, so we don't have context. There's no context coming in, right? So what do we do so that the tool actually produces code that eventually compiles and runs all the tests? Well, we're basically saying just inject artificial context. So it's configurable in the config file for the tool. You can tell what it is, but it is the default value, at least for the sort of generic context that Go package provides. And we also generate a warning. It all goes to the fabricator, our tooling for submitting diffs to be merged, which basically tells the developer, look, the tool only can do as much. So in this case, we're just injected the artificial context, but maybe you want to do something else. So basically, they will have an inline comment in their diff when they're reviewing it, and they'll be able to do something with it if they want to. Okay? And as I said, this is particularly, this example is related to test functions, but we have similar handling for functions that are used by third-party packages. So if a third-party package function takes one of the services function as a parameter to be called inside of the third-party package, which happens quite a bit, we'll do the same thing because we don't want to really can't modify signatures of third-party packages or functions in third-party packages. Water. All right, obviously, as I mentioned, there are limitations because not everything can be sort of discovered statically, and some of the limitations involve spurious context injection. So sometimes, like all the control flow graph algorithms that are available, and I think all static construction, all algorithms that construct control flow graphs statically, they have limitation in that they can have spurious edges between a function and a call site. And the more sort of precise algorithm, the longer time it takes to execute it. But all of them have this limitation. And we basically see this when the tool runs, that sometimes, and it's for basically it's related to polymorphism, that sometimes a function or the call site is marked as the one that needs to receive a context argument, even though the function that is actually called at the call site, it's not modified to do it, to take it. So basically that has to be handled manually. And all these limitations basically have to be handled manually by the service developers. The other one is function aliasing. So basically if you start assigning your functions to variables and pass them around, then there's basically statically, there's no way to track which function's signature has to be modified because all these, like some of these values are only sort of instantiated in runtime. And reflection, I mean, that's kind of almost a classic situation for all static analysis or transformation tools. That it's difficult to handle reflective code. Nevertheless, and this is super fresh. We're only just starting a sort of a larger scale experiment by running this tool on like basically hundreds of services, and this experiment is literally ongoing as we speak. But for this presentation, I only managed to try the tool on 5 of our production services. Obviously, I'm just calling them service 1 to 5, but they're really production services. And so this sort of gives you an idea of the sort of size of the services that we're dealing with. So it's hundreds of thousands of lines of code, which is actually nice. It's not millions because the tool actually runs in a very manageable time. Like the tool itself, on each of the services you tried it on, runs under 10 seconds. So it's kind of manageable. But this kind of shows you one metric of effectiveness of this tool. So basically, this gives you a ratio of the changes that the tool has made, or actually the changes that were needed to be done manually, to the number of changes that the tool has made automatically. So basically, the lower the better, and the ratio shows you basically what's the percentage of the manual changes that were required. So as you can see, it's all under 5%. So basically, more than 95% of modifications required for these services to build and pass the GoVet check was done by the tool. And at this point, out of those 5 services, with basically this ratio of manual changes, 4 out of 5 passed all the tests in CI. And for those 2, no manual changes were required at all. So basically, the tool ran, the service builds. And one of them builds, and one of them builds and runs all the tests in our continuous integration infrastructure. So for like as far as early indications go, this is not so bad, I think. And our sort of the ongoing experiment with I think there's basically 100 services that we tried on. It's actually fairly promising as well, but I don't really have concrete numbers, and I don't want to talk about it. So summary, we believe that don't know of any other tool that serves this particular role, and we believe that this will help tremendously reduce the sort of the grunt work, the manual, tedious work that would be otherwise required of our developers. The preliminary results are pretty promising, I think, and of course we want to test it in production. The fact that it runs all the tests in CI and the continuous infrastructure, it's a good indication, but we also have to test it in production. More services are incoming, and as we speak, I'm working on open sourcing this, so at some point it should be available to the community. So this was a super sort of fresh project. The other 2 are a little bit more mature. They have been around for a little while, both in the open source and within the company. I don't know if any of you have heard of the Jar and Fair. If you did, there's actually going to be an update on a little bit on the sort of extensions to this tool. So hopefully it's going to be interesting either way. But if you haven't, hopefully that's going to be really interesting. And that particular part of the talk is based on the work that has been done by. I mean, I should have said it. I don't think I did. All of this sort of collaborative effort, like my team basically as a whole works on these projects largely. And this paper was published at FSC this year. And it has been done by my team. The two other people that are mentioned here as our former colleague that's now betrayed us and went to the academia, Manu, and the other is an intern of ours from last year. Okay, so what's this about? Well, this is about null pointer exceptions. And this has been a big problem for us. As you can imagine, if you are sort of standing at on the sidewalk waiting for or trying to order an Uber and your app crashes, you kind of toss either the phone or at least the app and you pick something else, right? You hail a cab or you pick Lyft or whatever is available in Athens. So this is bad for us. It's bad for business, bad like in terms of revenue and all that. So, and it actually has been a big problem. Not only because of that, but also because if we discover what the problem is from the logs, sort of post-mortem logs, then it takes a significant amount of time to actually patch the apps. So there's an extended period of time between the discovery of the problem and the actual patch that goes to the users. Okay, so simple example of what can be happening. Super simple example, just used to illustrate what the tool actually does. So we have again, we have two functions. This time this tool is for Android, for Java. So obviously the examples are in Java. We have a function that tries to log something, and then on an argument, a toString method is being invoked, and of course there is another function that's calling that method that's calling log method, and it obviously passes null. So it's bad because clearly the null will go as an argument to the method log, and it will go to the code will try to invoke a method on a null value, and of course there's going to be a null pointer exception. So that's bad. The question is, what can we do about it? And there are multiple approaches. Ours actually is not super novel either, which I'm going to talk about soon. But I'm also going to tell you why it's actually cool and nice and effective. So one approach, and again, there are multiple, is to use sort of type-like mechanism to discover it, or to basically discover these statically, discover these types of situations statically. And the basic idea is to use annotations. So you ask your developers to use annotations. Our developers were actually fairly responsive, and because they knew that it would save them a lot of headache in tracing those bugs from runtime logs and all that. So that wasn't actually too difficult to convince them to start putting those annotations in. But what are the annotations? There's actually several, but the sort of the two basic ones are nullable and non-null. So basically, everything by default, if you don't use any annotations, everything in your code is going to be non-null. So basically, that would mean that you couldn't use null values at all. Otherwise, the tool would complain. But of course, people use null values for various reasons. And if you assign a null value to an argument, or if you return it from a function, then you have to use nullable annotation to indicate that this value can be null. And that's used to perform basically a bunch of checks. So the type checker, if you will, is going to go through your code, and it's trying to figure out if your assignments and then the references are obeying the sort of the discipline or not. And the checks, some of them are super simple. So basically, you can't use a null as argument to null parameter. So if you implicitly actually designate that the parameter should never be null, then if you decide to pass a null value to that function, to that method, then the type checker will complain. So you'd have to fix it. And another one is, if you dereference something that's nullable, you should check in an if statement whether this is null or not. Otherwise, it's going to be a problem. And we try to avoid, or wanted to avoid, annotating everything, including local variables. So we have a sort of a method level data flow analysis to sort of figure out what's going on with the local variables within the method. So we don't have to actually annotate local variables. But it's very limited. So how do types sort of rescue us in this situation? In the same example, first of all, yes, the first problem is that there are no annotations, so everything should be null-null. We pass null to as an argument to a method. The type checker would say, oh, don't do that. Like, it's an error. You can't do that. Okay? So how do we fix it? Basically say, OK, we're saying now that you can actually pass a null value to a method. So that error will disappear. But of course, because now you can pass null to log, you can't dereference it, because like, it can be null. So it's a potential null pointer exception. So what do we do then? Well, we have to put a check that basically says, oh, only dereference if you check that this is non-null. And that actually will fix the problem. So again, very simple example, but that's the principle under which this tool operates. So this tool has been around. These techniques have been around for a while. And in fact, people that are here from Facebook, maybe, there's a tool from Facebook called Infer that has an algorithm, or basically, it's a framework that has an algorithm that you can run on your code, which is called Eradicate, that will basically implement these types of checks and will tell you exactly the kinds of errors that I showed you. There's another one that's called Checker Framework. It's an academic project from UW. So we used those at some point, but because of the scale, this was problematic. And it was problematic for two reasons. One is our applications are large. And for large applications, these tools take a long time to run. So the compilation overhead was up to 5 times. So I think the 5.1 is actually the checker framework. The Infer tool is a little bit faster. But basically what this means is that we can run it. We cannot run it on every local build, which would be ideal for us, because we have a lot of developers. Developers don't want to wait until some part of your continuous integration infrastructure will come back to you saying that you forgot one annotation in your code somewhere, right? Which would be in hours. Like ideally, you would run it locally. You would fix everything locally, and everything is great. But it was infeasible, and we actually did run it at the sort of very last stage of our build pipeline, right before merging. But the other problem is, and again, this is because of the scale of the apps, is that there are hundreds of libraries, external libraries that are being used when developing these applications. And what to do with those? I mean, they're not annotated. Those tools they can't cope with these third-party libraries. So we have two solutions. So one of them is NullAway, which kind of takes care of the efficiency problem. And the other one, which is part of NullAway, is JarInfer, which tries to help with the third-party libraries. How am I doing on time? All right. So NullAway. Google, thank you so much. There's an excellent framework to write static checkers, basically. It's called error-prone. We've been working with the people on that team for a long time. That tool, NullAway, is based on error-prone. It's a plugin to error-prone. Basically, error-prone itself is a plugin to Java-C. And we use Checker Framework, which you could use to do the whole analysis, the whole nullness analysis. But we use only like a small portion of it to do this local data flow analysis on a per method basis. And our overhead, or NullAway's overhead, is basically 15%. So that has been running at Uber on every build of every developer on their local laptop for the last 2 years. And the sort of in terms of effectiveness of NullAway, we have basically less than 5% of in the field crashes after it has been deployed, and that's sort of the measurement is based on very carefully analyzing 1 month of sort of crash logs from real production applications. I think it was the Rider application. The nice thing is that there's basically 0% crashes in what we call a checked code. And what we mean by checked code is the code that basically has been annotated with NullAway annotations by the developer and pushed to the repository. And yes, there are obviously 5% is not so great. It could be 1% or 0% altogether. That would be amazing. But there are some sort of reasons why this is not the case. And the first main reason why we still have crashes is the third-party libraries. So NullAway was implemented with very optimistic assumptions about third-party libraries, but they were sort of making unreasonable things. So 64% of the remaining crashes, out of those 5%, obviously, they have been caused by the third-party libraries. The other ones are suppression. So when you ask developers to integrate NullAway annotations into their code, Sometimes they're like, that's too much. Like, I'm not going to deal with this particular method or with this particular file. So you can suppress NullAway annotations basically in your code if you don't want to deal with it or with them temporarily. And those temporary fixes, they basically result in additional crashes. And then also we have some parts of infrastructure, they're modifying code post or actually during the build. So there's a bytecode instrumentation framework that does certain things for tracking performance and such. And there were some cases when basically serializer or deserializer was writing null values into non-null fields that were annotated with non-null. But of course, the deserializer doesn't know that. So these were sort of the source of the remaining problems. So we do have, this is sort of an update on NullAway, we do have work ongoing, in fact, on trying to tackle the problem that's related to third-party libraries. So as I said, NullAway is very optimistic in what it assumes about third-party libraries without this additional support. So basically it says, okay, all parameters are nullable, so you can pass null to basically all library calls. And whatever libraries return to you is non-nullable. So you can rely on those two things. And that's not quite good enough. So our intern worked, and then it got integrated into the tool itself on the tool called jar infer that tries to make it less conservative. So what the tool does, it basically goes ahead and analyzes the bytecode of the third-party library. So obviously it's Java, so bytecodes are available, source code is not. And so far, super simple stuff has been implemented, but it's already becoming somewhat effective in detecting additional problems. So basically, the two things that are implemented are checks for parameters and for return types. So basically, to relax those optimistic assumptions, if a parameter is always dereferenced inside of a method, then it's going to be non-null. And what it means that to be always dereferenced is that it's in a basic block that's always reachable from the entry block of the method. So it's a very simple thing, no data flow analysis actually. And if a method returns null in any case, in any way, I mean at any point, in if statement, wherever, it just checks for whether a null is returned at all, then it means that the value is nullable or can be nullable. And jar infer has been implemented as a Walla plugin. So again, thanks IBM for helping us with open source projects. And it builds a control flow graph for each method. So it's different from the other tool, but the control flow graph was global. This is just per method. And basically finds cases, those two cases that I mentioned, whenever the parameter is dereferenced, if the parameter is dereferenced always, and if the null value is returned ever. And basically rewrites the bytecode to put the annotations into the bytecode so that the tool can actually figure this out. I mean, they basically have additional information to infer. And that already helped finding, like just right after deployment, it helped us find like 21 new null pointer violations in our code base that would be otherwise undetected because they were related to third-party libraries. The analysis actually takes a long time because we have a lot of libraries. So 10, 15 minutes the first time you have to run it. But fortunately, you don't have to run it very, very often. It's mostly being run if you change the version of the tool itself. Because, I mean, obviously assumptions can change the way that the bytecode is processed. You also have to rerun it on specific libraries, but the analysis time is actually linear in the bytecode size. So if you change the version of the library or update a library, you have to run it, but it's going to be sort of a fraction of that initial investment that you have to do at the beginning. The downside here is that at this point, due to the rule number 2 from the previous slide, we actually have had a lot of false positives, basically from real methods that return, that are indicated to return null values. So we deal with those basically with models. Okay, summary of that project. It's practical and fast nullness checker for Android. We have effectively reduced number of crashes at Uber using that tool. And we also have this tool called jar infer that's basically helping with dealing with the third-party libraries. I have another project to talk about, but of course that's not going to happen. But if you're interested in other projects that our team is working on, let me scroll or go straight to the last slide, to the summary slide. We have our website that describes some of the projects and has references to our papers and talks about a little bit about the team members. But basically, that's the summary. There are a lot of problems, even at our scale, which is already large, that have to be tackled. Some of them, we use some of the open source infrastructure to help us, but we have to build custom solutions more often than not. But we're also trying to contribute back. So the NullAway is an open source. The GoContextRefactor will hopefully be soon. The other tool that I was planning to talk about, Nanoscope, is also open source. This is a little disclaimer from the lawyers. You probably don't see it, which is probably for the best. And a shameless plug for another piece of work from our team that I was actually not involved with. It's a presentation of my colleague and manager, Raj, which is going to be on Thursday. And it's also about actually dealing with problems at scale, because we're one of the largest Swift shops in the tech, basically, realm. And this is about optimizing some of the, basically, compiler optimizations for Swift code. So please come and join us also at that presentation. And thank you so much. I wish I could talk about the third project as well, but lunch is coming, and everybody's probably hungry. So thank you for your attention, and thank you for staying. And if you have any questions, obviously, I'm happy to answer. Yeah, of course.
The first project where you talked about introducing an additional parameter, and the thing that struck me was this was like your favorite aspect-oriented programming at some level.
I'm not actually. Oh, sure. Sorry, no mic. So basically, the question is whether the problem that we're trying to solve with the refactoring tool is similar to, or could be solved with a tool that's basically implements aspect orientation. And I think, I think that's true, but I don't think that's, it's feasible. This type of support actually exists for Go. Plus, I'm not sure that actually, because actually you need to have control flow information. Yeah, so you could do the actual code modification, probably, but not the whole analysis that's required for that.
The issue that you mentioned about you have to be careful about the root nodes.
Like you have these library functions at the bottom, and then you kind of propagate upwards through the call chains until you reach, whatever the entry points of the service are. So you kind of have to know, But you need some version of control flow analysis for that, because otherwise, you can add context to all the functions in your code, but that's probably not what you want, right? You want to minimize the changes and only add them on the paths where it's really required. So if you don't have that information, then it's probably not going to be effective.
Do we have other questions from the audience? I think people are getting ready.
Yeah, lunch is important. So if you want, please find me. I'm more than happy to talk. I'm here until basically the end of the world. So Friday, basically. Yes. So please find me and talk to me if you want. Thank you so much.